So question 1a is 4x divided by 2. That slash means divide by 2. Now you can either have it that way or you can go write it as a fraction. It makes you just see things a bit clearer. So I need to go see what I can simplify by cross-canceling or canceling out by dividing them, anything like that. And remember, when we divide with exponents, we minus them. In this case, we don't have an exponent, but I can see that in 2 and 4, I find the same factors, which means that I can go and say 2 divided by 2. Oh, my 2 looks funny. And then 4 divided by 2. Okay, so I can divide on both sides. But when I look at the x, there's nothing that I can divide with because this here at the bottom does not have a variable. Okay, so there's only a variable at the top. So now let's go simplify it. So if I say 4 divided by 2, I get 2. And then I have an x left. And if I divide 2 by 2, I'm going to have 1. But we never write it as over 1. It falls away. So my final answer is 2x. So get the next one. So again, it's written as 9 divided by 27y. It's the same thing as saying 9 over 27y. So I have to go look at what can go into 9 and into 27. And with my variables, I only have a y at the bottom, nothing at the top. So I know that at the bottom, I'm going to be left with a y. So if I go simplify, 9 can go into 9 and it can go into 27. So 9 divided by 9 is 1. And 27 divided by 9 is 3. And I'm left with the y at the bottom. And that is your final answer. We'll go look at C now. We have 28x. And I'm already going to write it in a fraction form over 4. So what can go into 28 and into 4? Remember, when we work with variables, and coefficients, the number in front of the variable, divides normally. We do normal plus, minus, divide, multiplication with numbers. Okay, so I can see that 4 can go into 4 and 28 can go in, 4 can go into 28. This is where knowing your timetables is extremely important. So if we go rewrite that, 28 divided by 4 gives me 7. Again, I only have an x at the top, nothing at the bottom, so I'm going to keep my x at the top. And then 4 divided by 4 is 1, but we do not write it like that. We just write 7x. That is my final answer. Okay, if we go down to D. So D, just change this up. Okay, doesn't want to change anything. There we go. So if I look at D, D is 24. Again, I'm going to write it as a fraction already over 6x. Now I have variables that are coefficients that are the same. I can divide 6 into both of them. And then with the variables, I have an x here, but I have nothing here. So at the bottom, I will keep my x. There's nothing to divide it with. But 6 divided by 6 is a 1. We never write the 1 in front of the variable. And then 24 divided by 6, that gives me 4. There we go. And that is your final answer then. That will be the same that you have to do for E and for F as well. Again, just dividing in. But I'm going to be doing F for you guys. So F is 21xy over 35x. Again, I'm going to look at what can go into the top and into the bottom. Then also, I have variables this side. So I have an x and an x that I can sort out. So let's see, what can go into the top and the bottom? Well, I can see that 7 can go into both of them. And again, please note that I am multiplying and dividing by the same number at the top and at the bottom. You can't go and change those, okay? Have a two different one. It has to be the same one all the time. So now if I go right to 21 divided by 7 is 3 at the top. 35 divided by 7 is 5 at the bottom. The two x's, because they have the same variables, there's nothing to exponents, there's nothing I can minus from each other that there will be anything left. 1 minus 1 is 0. Anything to the power of 0 is 1. So all you can think of it is just taking it out. So I don't have x's left. But what I do have left at the top is a y. Okay. So I am going to be writing y over here. And that is your final answer. Question 2 tests your laws of exponents. So things you have to remember is when you multiply, you add exponents. When you divide, you minus exponents. And when you have to plus terms, you need to go find like terms. That's plus or minus, okay? Let's take that one out. I want to say when you plus or you minus, you have to remember that you go find the like terms. So let's jump in. So firstly, let's just write it in a different color here. So I have x squared times x to the power of 3. Again, multiplication, I have to plus them. So I'm going to have 2 plus 3, which gives me x to the power of 5. Next one, I have brackets. Now, when you see brackets, you need to remember you have to multiply the exponents. So I have x to the power of 2 on the inside and 3 on the outside. So in this case, my answer would be x to the power of 6 because I need to multiply the two. So let's jump back in. Question C. I have x to the power of 5 divided by x to the power of 2. So if I divide them, I have to minus them. This one over here. So that's 5 minus 2. So my final answer is x to the power of 3. Then for the next question, for the last one, just going to remove these ones quickly. For the last one, I have 2x to the power of 2 times 3x to the power of 3. Now let's start here by the first thing. When we have coefficients, again, plus or minus, multiply or divide, you do them as normal. So in this case, 2 times 3 would give me 6. Now, when I work with my exponents, this one's here, when I multiply them, I have to plus them. So my answer is going to be x 2 plus 3. These two plus with each other. So that gives me 5. And that is your final answer. Simplify the expressions. So first one was 2x times, I'm going to just make a dot there for times 3, plus 4x times a 2. So remember, whenever we're doing any sort of sums, we always go and we apply BEDMAS. So we're going to start here. Because we're doing variables and exponents, and there's a plus sign, we'll look for like terms. But first, you need to go sort out each one of these. Remember, we do multiplication before we look at even touching this plus. So let's sort out the first one. Coefficients, the number in front of the variable, we multiply as normal. So 2 times 3, that will give me 6. And there's no other variable on this side to multiply with, so it's just 6. Okay, so I'm going to plus that with the other side. So let's just change the colors here. So this one here, again, the coefficients normal, 4 times 2, that gives me 8. And I have the variable. Now, very importantly to remember, when we look for like terms, we have to make sure that the variables are exactly the same along with the exponents. Now, both of these have an exponent of just 1 because there's nothing written there. So they are like terms. They look exactly the same. And therefore, we can add them together. So 6 plus 8, that gives me 14. And I don't change the variable at all. I just go and I rewrite it. And that is your final answer there. The same will be for B, C, and D. There's nothing different to it. So I'm going to move on to question 4. So with question 4, we have brackets now. So we have 4x plus 3 plus 2. Again, we always follow BETMA. So BETMA tells me I have to multiply first and before I do addition. So this 4 is busy multiplying with the bracket. Everything in front of a bracket has to multiply with everything inside. So if I go and I rewrite this, I'm going to have 4 times x. It multiplies with an invisible 1 in the front. 4 times 1 is just 4x plus 4 times 3. That gives me 12. And now I've removed the brackets because I multiplied in. So I just add the 2. Again, I go look for my like terms. Just change this up. Like terms, I have 4x here, but I don't have any other x's. So the next thing I look for are my constants. There they are. So I'm going to have 4x plus 12 plus 2 is 14. That is your final answer there. This will be exactly the same for B and C. So go try it on your own.